In the spring chill of 1950, deep inside the briefing halls of the Soviet Air Force, the laughter was thin and metallic, the kind that hides a trace of fear behind arrogance.
Look at this.
The
An
Americans, the
intercontinental
officers
bomber. They must
agreed,
think we are
were playing
fools
engineer
indeed.
again. Boeing's new intercontinental jet bomber, as Washington called it, was nothing more than capitalist fantasy. A machine too big, too heavy, too fuel-hungry to ever leave the runway. Soviet analysts, emboldened by the recent success of the Tu-16 and Myasishchev M4 projects, circulated a secret memorandum to the Kremlin's Defense Council. The report concluded that the United States lacks both the metallurgy and the mathematical discipline to sustain a jet aircraft of such mass over transcontinental ranges. In Moscow, that statement drew nods of agreement. The Americans, after all, were carpenters of industry, not artisans of aerodynamics. At that time, Soviet engineers were convinced that elegance equaled superiority. Theirs was a nation that had clawed miracles from scarcity, designing machines that performed not because of abundance but in spite of its absence. To them, American aviation looked clumsy, inefficient, oversized. They measured genius by precision, not scale. The Yankees, one Tupolev engineer scoffed in 1951, build airplanes like they build refrigerators, large, loud, and leaking fuel. The remark captured the Soviet belief that technical refinement was inseparable from ideological virtue. The USSR's aircraft were compact, disciplined, and tightly integrated. American designs were sprawling indulgences of capitalism's obsession with mass production. Meanwhile, in Wichita, Seattle, and Long Beach, something else was happening. Something the Soviets could not quantify. An experiment not only in flight but in systems orchestration. At Boeing's Plant 2, the B-52 prototype sat skeletal under the floodlights. A cathedral of riveted aluminum stretching nearly half a football field in length. Engineers worked through the night wrestling with weight ratios and wing flex while in another state entirely. Pratt & Whitney technicians were testing the J-57 engines that would one day propel it. To an outsider, the chaos looked uncoordinated. To those who understood, it was choreography, an industrial ballet executed at national scale. Soviet intelligence, watching from afar, saw only the delays. The B-52's troubled gestation was reported as proof that American industry was losing its technical edge. "They will never overcome the instability of such a design," wrote one Soviet correspondent to Krasnaya Zvezda. "It is a project of excess, not endurance." Yet across the Pacific, Boeing's engineers quietly solved problems that Soviet planners hadn't imagined. Laminar airflow over swept wings, modular fuel distribution, interchangeable engine mounts. These were not acts of genius in the traditional sense. They were acts of persistence. The kind of innovation born from a culture where failure was not punished but mass-produced until it became reliability. And so the skepticism deepened. The Soviet Union looked at the B-52's cost, its complexity, its monstrous proportions, and saw weakness. America looked at the same numbers and saw insurance. 8 engines meant redundancy. Massive wings meant lift over distance. Cost meant investment in permanence. While the USSR measured success by immediate function, the United States measured it by scalability, a metric invisible to those trained to think in scarcity. Then came April 15, 1952. The day was clear at Boeing Field. Cameras rolled, engineers watched, and a small crowd of Air Force officers stood silent as the prototype began its takeoff run. The noise was not merely mechanical, it was industrial, a thunderous declaration of capability. The B-52 left the ground with a slow, impossible grace. And for a moment, disbelief hung heavier than the jet itself. When the Soviet observers received the footage days later, the tone in Moscow changed. No one laughed. The impossible had taken flight, and in that moment, the entire ideological architecture of Soviet aviation, the faith that technical purity could outweigh industrial might, began to tremble. To understand why the Soviets dismissed the B-52 as a fantasy, one must understand the architecture of their thinking, a logic built not on abundance, but on survival. Since the 1930s, Soviet engineering culture had evolved under the relentless pressure of scarcity. Every gram of aluminum, every liter of aviation fuel, every hour of machine time had to be justified to a central planner. From that constraint grew a doctrine that equated simplicity with strength and efficiency with virtue. It was an engineering theology born in famine and war, where the ability to create something elegant from nothing was proof of national superiority. In that moral universe, America's vast consumption of resources was not a symbol of power but of decadence. In the aftermath of World War II, the Soviet Union surveyed the ruins of Europe and saw validation of its philosophy. The Red Army had triumphed with the Tu-2, the Il-4, and legions of Yak fighters that were durable, maintainable, and brutally efficient. When the United States rolled out the B-29, gleaming, complex, and heavy with automation, Soviet engineers saw excess. They did not yet understand that excess, when systematized, becomes strategy. So when Boeing proposed the B-52, a bomber larger and faster than any before it, Soviet analysts applied the same arithmetic that had once served them well. Limited fuel supply, limited runways, limited metallurgical capacity. By those metrics, such a machine could not exist. Their logic was reinforced by doctrine. The Soviet Air Force's strategic model in the early 1950s relied on proximity. Forward bases in Eastern Europe and Asia that could bring bombers within striking distance of NATO. Range, therefore, was a luxury, not a necessity. The Americans operating across oceans needed global reach and thus designed for endurance. Yet to the Soviet mind, that very redundancy, 8 engines, massive fuel tanks, reinforced landing gear, looked like inefficiency bordering on madness. They were prisoners of their own design paradigm, success measured by how much less one could use, not by how much more one could sustain. Even within Soviet academia, this perception hardened. At the Zhukovsky Air Force Engineering Academy, lecturers warned students against the American disease, a design culture that substituted material abundance for ingenuity. They contrasted the sleek, minimal Tu-16 with what they derisively called the Boeing bloat. The Soviet Union prized the artist-engineer, the single genius solving for perfection under constraint. America was seen as the land of committees, accountants, and assembly lines. What the Soviets failed to recognize was that the committee was the weapon. In the United States, industrial democracy, the ability of thousands of minds to collaborate across states, companies, and time zones, became a force multiplier. The B-52 project was not a triumph of one genius, but of systemic capacity. Boeing could design a part in Seattle, test it in California, have it fabricated in Ohio and assembled in Kansas, all coordinated through a bureaucratic nervous system that the Soviets simply did not possess. In Moscow, this was invisible. They saw the outputs but not the organism. This blindness was reinforced by ideology. Marxist-Leninist economics taught that capitalism was inherently wasteful, unable to plan efficiently for war. Soviet planners genuinely believed that American production lines tuned for profit rather than purpose would collapse under the weight of their own inefficiency in a sustained conflict. The irony was brutal, that very inefficiency, the willingness to overproduce, to build multiple prototypes, to tolerate error, was the mechanism through which American industry learned faster than its enemies. By 1952, Soviet strategists still believed that jet bombers belonged to their design vocabulary, not America's. They had the Tu-16 in service, the M4 on the horizon, and a bureaucracy trained to believe that quality born of discipline would always defeat quantity born of excess. They did not yet see that America's excess was disciplined, that behind the B-52's immense wingspan lay a nation's logistical intellect. The Soviet Union's engineers could calculate thrust, drag, and fuel consumption. What they could not calculate was the strategic potential of a production line that never slept. What the Soviet analysts could not see was that the B-52 wasn't just a triumph of engineering. It was a triumph of industrial architecture. An organism grown from the marrow of an economy that had learned to weaponize abundance. While Moscow's engineers worked inside vertically integrated ministries, Boeing thrived in a horizontal ecosystem that spanned the entire continental United States. Each bolt, each turbine blade, each avionics circuit flowed through an invisible network of subcontractors, suppliers, and research centers, all coordinated by a new kind of intelligence. The managerial system. This was America's real invisible advantage, not merely its machines, but its ability to make machines that make machines. In the 1950s, Boeing's design process resembled a living organism more than a hierarchy. At the center were engineers with slide rules and sleepless eyes. Surrounding them were procurement specialists, test pilots, logistics officers, and economists who spoke the same operational language. Production as warfare. The B-52 emerged not from a single breakthrough, but from the fusion of countless iterative processes, each tested, discarded, and improved. Soviet planners accustomed to linear development models had no conceptual map for this chaos that produced order. Pratt & Whitney's J-57 engine, the beating heart of the B-52, was itself a monument to systemic resilience. It was overbuilt, over-engineered, and absurdly redundant by Soviet standards. Yet it could operate in polar conditions, tropical humidity, or monsoon dust without failing. While Soviet engines like the AM-3 demanded constant maintenance, the J-57 could run thousands of hours between overhauls. Why? Because the United States had industrialized quality control as if it were ammunition. Factories didn't just assemble. They measured, standardized, and cataloged until the system itself became a kind of mechanical immune response. Even the way Boeing designed its assembly lines spoke to a philosophy that mystified Soviet observers. Unlike the USSR, where entire factories were repurposed for each new aircraft type, American plants were modular. Tooling, jigs, and production sequences were built for interchangeability. A design not for one plane, but for generations of them. A rivet pattern on the B-47 could reappear, scaled on the B-52. A wiring harness for one prototype could be replicated by the 1,000 without a pause in the supply chain. This was industrial continuity masquerading as innovation. Then came the integration of command. The newly formed Strategic Air Command, SAC, under General Curtis LeMay, did not merely want an aircraft, it wanted a permanent airborne weapons system. To meet that demand, Boeing had to design an airplane that could live in the sky as much as on the ground. The company's collaboration with the Air Force Materiel Command created a feedback loop unprecedented in scale. Field data from test flights in Texas could trigger design modifications in Seattle within days. Logistics updates from Guam or Fairchild AFB could alter production schedules in Wichita within weeks. This synchronization was invisible to the Soviets, who still treated production and operations as separate bureaucracies. And hovering above it all was money. Not the corrupt luxury the Soviets imagined, but structured investment. The Pentagon's procurement budgets didn't simply buy planes, they bought time, the one resource every planned economy lacked. Delays could be absorbed, redesigns funded, risks tolerated. The Soviets watched in disbelief as Boeing's failures became stepping stones instead of tombstones. Where the USSR designed to avoid error, the US designed to exploit it. By 1952, when the B-52 finally rolled from its hangar, it represented something more profound than technology. It was the first aircraft in history to be manufactured as part of a self-sustaining ecosystem. A machine that could not only fly farther and faster than its rivals, but could be maintained, refueled and rebuilt without ever halting the flow of industrial momentum behind it. The Soviets had mastered the art of building airplanes. The Americans had mastered the art of building systems that could build airplanes forever. On the morning of April 15, 1952, the sky over Boeing Field shimmered in the pale light of early spring. The prototype stood at the end of the runway, a silver leviathan gleaming with both arrogance and purpose. At 480,000 pounds, the XB-52 looked less like an airplane and more like a technological declaration. The spectators, Air Force officers, engineers, journalists, held their breath as the 8 J-57 engines roared to life, spitting blue flame in industrial defiance. The air vibrated with the rhythm of turbines that no Soviet machine could yet match. And then, almost imperceptibly, the giant moved, gathering speed, lifting its nose and rising into the air as if the laws of gravity themselves had yielded to industrial will. The first flight lasted only 2 hours and 21 minutes, but it was enough to rewrite the vocabulary of strategic aviation. Within days, the footage reached Moscow. The Soviet attachés who viewed it reportedly sat in silence. "Impossible," one engineer muttered, not in denial but in awe. The Americans had done what the Soviet doctrine deemed impractical. They had built an intercontinental jet bomber that could carry over 40,000 pounds of ordnance across oceans without refueling. What unnerved Soviet analysts wasn't just the machine itself, but the scale implied by its existence. If the United States could build one, it could build hundreds. And indeed, it did. Between 1952 and 1962, Boeing produced 744 B-52 Stratofortresses, each iteration refined yet identical enough to fit seamlessly into SAC's global logistics chain. Production spanned 8 major variants, but every one of them shared the same DNA: durability, adaptability, and range. The statistics were staggering. With a combat radius exceeding 4,500 miles, the B-52 could launch from the continental United States, strike deep into the Soviet heartland, and return without foreign bases. Its 8 engines generated nearly 136,000 pounds of thrust, enabling a payload capacity that dwarfed anything in the Soviet arsenal. Meanwhile, the Soviet Union's closest counterpart, the Myasishchev M4, was already showing its limits. Its engines strained at high altitudes, its range was insufficient for true intercontinental missions, and its maintenance cycles were punishing. The Tu-95 Bear, though formidable, relied on turboprop propulsion, efficient but symbolically archaic in the jet age. Soviet engineers justified this by claiming superior fuel economy. In truth, they lacked the metallurgical and industrial base to mass-produce reliable jet engines of the B-52's caliber. America had industrialized jet power before the Soviets could industrialize precision metallurgy. But the shock went deeper than technical inferiority. It was doctrinal collapse. The B-52's emergence invalidated entire branches of Soviet strategic thought. The USSR had bet on speed, altitude, and range being mutually exclusive. The B-52 combined them all. They had assumed that intercontinental strike capacity required forward basing. The B-52 proved that a self-contained airborne deterrent could patrol indefinitely from U.S. soil. They had calculated that no nation could sustain such a fleet economically. Yet the United States produced, operated, and maintained hundreds simultaneously. The Americans weren't just flying higher, they were flying longer, supported by a logistical infrastructure that turned the sky itself into a supply line. Inside SAC headquarters, General Curtis LeMay pushed the concept further. He envisioned a force that never slept, bombers constantly airborne, refueled mid-air by fleets of KC-135 tankers, each rotation governed by clockwork precision. To the Soviets, this was madness. The fuel consumption alone was greater than their annual aviation budget. Yet to the United States, it was insurance. The cost was not a burden, it was a signal, a deliberate display of what unlimited industrial stamina could achieve. By the mid-1950s, the psychological impact was measurable. Soviet Air Defense Command began restructuring its entire radar and interceptor grid to counter an enemy that could appear from any direction at any time. Every new B-52 sortie forced the USSR to spend millions on early warning systems, missiles, and jet fighters just to keep pace. The bomber wasn't just a weapon, it was an economic trap. Each flight drained rubles from the Soviet treasury long before any bomb ever fell. For the first time since 1945, the Soviet leadership confronted a terrifying possibility: that America's greatest weapon was not its technology, but its capacity to produce too much of it. The B-52 was proof that in the calculus of Cold War deterrence, abundance was the ultimate precision. In the years that followed, the B-52 became more than an aircraft. It became a psychological continent in the Cold War landscape, a horizon of power that the Soviets could never quite reach. To the planners in Moscow, its silhouette on radar screens was a reminder that industrial capacity could be as lethal as nuclear payloads. Every mission flown by the Stratofortress was an arithmetic of humiliation. Each takeoff represented the manufacturing might of hundreds of factories, each refueling a demonstration that America's logistics were as infinite as its ambitions. Soviet air defense commanders were forced into a posture of reaction. The B-52's endurance and flexibility destroyed the neat geometry of Soviet planning. The old defense rings built around Moscow and key industrial centers were designed to intercept bombers with predictable flight paths. But the B-52 could come from anywhere. Polar routes, Atlantic arcs, Pacific detours, all supported by mid-air refueling networks that seemed to mock the very notion of containment. For the first time, the USSR faced not a bomber fleet, but a strategic ecosystem in motion. Intelligence reports from the late 1950s reveal an almost theological anxiety. One declassified Soviet memorandum described the B-52 as a machine that embodies the capitalist belief that everything can be multiplied. The report lamented that the Americans have turned redundancy into doctrine. This was no longer about airframes and engines. It was about metaphysics, about two civilizations with opposing interpretations of control. The Soviet Union engineered for constraint. The United States engineered for overflow. The production data itself told the story. By 1958, Boeing was producing one B-52 every 5 days. Entire production blocks were operating in parallel, each aircraft emerging from its hangar nearly identical to the last, yet each backed by an expanding infrastructure of maintenance depots, fuel logistics, and spare parts. Even when production stopped in 1962, the industrial ecosystem behind it did not die. It evolved into a permanent maintenance economy. Every rivet, every turbine blade, every hydraulic line was cataloged, stockpiled, and replaceable. America had created a machine designed not just to fight wars, but to outlive them. Inside the Soviet design bureaus, morale began to fracture. Engineers who had once mocked the B-52's bulk now studied its schematics with reluctant admiration. The Tu-95 remained a marvel of efficiency, but efficiency had become irrelevant. The Americans had shifted the metric of victory itself. They weren't competing for elegance anymore. They were competing for endurance. "They build airplanes as if they were automobiles," admitted one Soviet officer in a 1959 technical exchange. The statement was intended as criticism. History remembers it as confession. As the 1960s dawned, the ideological ground beneath Soviet aerospace began to erode. The B-52 had forced them to confront a paradox, that a machine could be both excessive and efficient, both wasteful and immortal. While the USSR continued to produce refined aircraft in limited numbers, America flooded the skies with functional redundancy. And with each passing year, the strategic asymmetry widened. When the Cuban Missile Crisis arrived in 1962, it was the deep, steady drone of B-52s on airborne alert that defined the soundscape of deterrence. The Soviets listened and understood that America's response time was measured not in hours, but in production cycles. By the late 1960s, the realization was complete. The B-52 had become not just an aircraft, but an argument, a proof that the industrial engine of democracy could outpace the bureaucratic precision of central planning. The Soviet Union, for all its scientific brilliance, could never replicate the system that produced it. In the Cold War's unspoken arithmetic, the B-52 was the equal sign between imagination and execution, and the USSR, for the first time, was on the wrong side of the equation. By the time the 1970s arrived, the B-52 was no longer just a bomber. It was an anachronism that refused to die. Designed in the era of slide rules and riveted aluminum, it continued to fly through generations of warfare that its creators could never have imagined. When Soviet officials watched footage of B-52Ds dropping bombs over Vietnam in 1966, they were forced to confront a haunting reality. The same airframe that had terrified them in 1952 was still operational, upgraded, maintained, and lethal. No Soviet aircraft of that vintage remained in comparable service. The B-52 had outlived its enemies, its designers, even its doctrine. It was not a weapon of the atomic age. It was a civilization made airborne. That longevity was no accident. Boeing had engineered the Stratofortress with a degree of foresight that bordered on arrogance. The aircraft's internal architecture, its wiring channels, modular compartments, and redundant systems made it endlessly upgradable. The same philosophy that once seemed excessive now revealed its brilliance. Overbuilding was future-proofing. The B-52 could accept new avionics, radar, and weapon systems without structural redesign. The Soviets, by contrast, built each generation of bombers as discrete masterpieces, precise, elegant, and doomed to obsolescence. The Americans had built a machine that could evolve without rebirth. Behind this endurance lay a deeper truth. The industrial culture that produced the B-52 was not a singular moment, but a self-sustaining ecosystem. Decades after the last airframe rolled off the Wichita line, the network of suppliers, technicians, and logistics bases still thrived, servicing the fleet as if the war economy had never ended. Every B-52 that took off from Barksdale or Minot Air Force Base carried with it the ghosts of thousands of factories that no longer existed but whose blueprints, tolerances, and production records were preserved in federal archives. It was industrial immortality encoded into steel. For the Soviet Union, this endurance was devastating. They had believed that superiority was measured in breakthroughs, new engines, new wings, new materials. America had proved that superiority was measured in continuity. By the time the USSR fielded the Tu-160 in the 1980s, the B-52 had already logged millions of flight hours, crossed every ocean, and bombed in every major war zone since Korea. The Tu-160 was faster, sleeker, more advanced, and utterly irrelevant. The B-52 was not competing in performance, it was competing in survivability of concept. In the 1990s, long after the Soviet flag was lowered over the Kremlin, a retired Russian aerospace engineer named Vasily Yegorov gave an interview to Izvestia. When asked what he thought of the B-52, he paused for a long moment before answering. "We built for performance," he said quietly. "They built for permanence." It was not a compliment but an epitaph for a system that had mistaken efficiency for endurance. Even today, the B-52 continues to fly, refitted for cruise missiles, precision strike, and electronic warfare. It is expected to remain in service past 2050, approaching a century of operation. Its survival is not merely technological, it is philosophical. It embodies the American conviction that scale and time can be engineered into strategy, that a machine can be both artifact and instrument. It is the physical manifestation of industrial stamina, a metal testament to a civilization that never accepted limits as natural law. The Soviets once laughed at the absurdity of a jet bomber too large to fly. History has repaid that laughter with silence. The B-52 still moves through the sky, engines roaring like a century compressed into motion, a living reminder that in the war between scarcity and abundance, between precision and persistence, between ideology and industry, America built the one thing the Soviet Union never could, a weapon that outlasted an empire.